Hello, it's Keith here, and this is lesson 10 of the multi-platform series of my Z80 programming tutorials. Now, if you catch last time, we started making a simple Pong game and we had the paddle of the player moving, but there wasn't any ball or any computer player. You can now see we've got those, we've also got a score, and we've got some simple game logic. Now, this lesson series of 2 lessons was designed for one of my patrons who wanted a very simple game example that they could learn from. So this is what I've got here, and let's have a look at the code we've made today. So I'm going to assume you saw last week's lesson, and if you didn't, please catch up on it. But basically a few things have been added. We've added some new parameters for the extra logical objects we need to control. So we've now got a ball position in X and Y. We've got a move, which is the amount that's added to the position each time. So this will be either a 1 or a -1 for the X position and the Y position. We've got a score, because we need to keep the score. We've got a CPU position, which is the position of the computer controlled player. And so we have to set all of these up at the start of the code. So you can see here we're starting the ball's movement, and the X position starts at -1, so it will be moving to the left, and the Y position is 1, so it will be moving down, and the CPU position is defined just here, and we define the CPU at the far right hand of the screen. Now the CPU control is very basic. The player can move left, right, up and down, but the CPU only moves up and down. It was only very simple what we were trying to do. You saw last time we were using the draw paddle command to clear and to define the position of the player. We're using the same draw paddle command to do the CPU as well, and we're using a draw ball command to just draw the ball. It's very simple. It just locates a position on the screen and draws the accumulator as a text character, so nothing too special there. But you can see here we've got a lot of new code here. Now the first thing we need to do is we need to work out what we're going to do with the CPU. The CPU's logic is very crude. It looks where the ball is. If the ball is above the middle of the paddle, the CPU moves up. If the ball is below the middle of the paddle, the CPU moves down. So here we're loading in the CPU position and the ball position, and then we're decreasing the position of the ball by 1 because we want to aim for something resembling the middle of the paddle. The paddle's 4 tall, so we can't aim for the exact middle, so we're just subtracting 1 to get a bit closer to the middle here. And then we're comparing the ball position to the paddle, and if we find that there is a match, then we don't need to move the CPU, so we just skip down here. If the CPU is too high, then we need to move down, but we do have a problem here that we need to check that the bottom of the paddle isn't going to go off the screen. If it did this on the Spectrum, it would actually corrupt some of the memory. So what we do is we then check the Y position of the paddle, and we check if it is equal to the height of the screen, 23 minus 4, because the paddle is 4 units tall. If the CPU is already at the bottom of the screen, then we need to skip the next bit, so we just do a skip here. But if it's not, then we move the CPU down. If we've got to here, however, we need to move the CPU up. Because we jumped here, if the CPU was below the ball when we did this compare here, so we need to decrease L here. So once we get to here, we've updated the CPU position to aim, roughly speaking, for the ball. Now, of course, we would want better logic in the real world, but it's just an example. Now we get back to the code we saw last time. This loads in the current joystick buttons here. Then it actually processes the new position of the cursor here. The cursor code handles all of the movements of the player. It doesn't actually draw the player though. When we get to here, we want to actually move the ball. Now the position of the ball is defined by ball XY, and the direction the ball is moving is defined by ball move. Now you can see we've got DE here, and we're going to use these to remember if we need to flip the moving direction of the ball. Now the ball will need to be flipped if it hits either the paddles or the top or the bottom of the screen. And so we're going to do all of the checks, and then at the end we're going to flip if it's required. So we're going to use D here to remember if the ball needs to be flipped in the X direction, and E if the ball's movement needs to be flipped in the Y direction. Now when it comes to moving the ball, it's very straightforward. We take the X position of the ball, we add the X movement of the ball, which is either going to be 1 or -1, and we just store it back to the H here. So that is just very easily adjusting the X position. Now what we want to do is we want to see if that new X position is actually colliding with anything important. So first we check if the ball has gone over the screen on the left hand side or the right hand side. Now if the ball has gone over the left hand side, this is a loss for the player. If it's gone over the right hand side, then this is a loss for the CPU. So what we do is we load in the memory address of one of the scores, and then we increase that score depending on which player has just won a point. At this point we now need to reset the ball position. So we reset the ball position to the center of the screen here. So once we've checked the ball X position, we do the same for the Y position. We load in the current Y position of the ball here. We add the Y offset, which will either be 1 or -1 here, and we update the Y position in L here. Now we need to do the same and check if the ball is at the top or the bottom of the screen. So if the ball is at the top or the bottom of the screen, we need to run this over Y routine here. If it's not, then we just skip over that. Now, flipping the X or Y position of the ball is very easy. All we do is we increase D or E here. Now, the rules of this code is that if D or E is 0, then the ball doesn't need flipping. But if it's anything other than 0, then it does need flipping. So you can see here, we're just doing an inc of E here just to flip the Y position. And then we're storing the current position of the ball back from HL, which we updated here, of course. The next thing we need to do is we need to check if the ball has actually hit either of the paddles. We do this with this check paddle hit routine here, and we load in the current position of the player here and then run the routine, and then we load in the current position of the CPU and we load the routine. The routine will do either the player or the CPU. When we get to this position, we need to check if we need to flip either the X movement or the Y movement of the ball. So all we do is we load in E and we check if it's 0. If it is 0, then we don't need to flip the Y. But if it's not, then what we'll do is we load in C, which is our movement of the ball, as you can see here. And then we just use the neg command to flip it from a 1 to a -1 or vice versa. Then we do the same for the X position. We load in D, see if it's not 0. If it isn't 0, then we load in B, we negate it and we store it back. Again, flipping the 1 to a -1 or vice versa. Then we store the new ball move in BC. Note that DE is not stored anywhere because this is just a set of flags effectively to check if at any point in this the position needs to be flipped. At this point we've now handled the movement of the player, the CPU and the ball. So what we need to do next is just show the score and the other objects to the screen. So we locate to the middle of the screen, we show the score onto the screen, and then we load in the ball position and we use the draw ball routine to show our ball, which we're just using a letter O for. Now we load our CPU position and we draw our paddle, and then we load our player position and we draw a paddle. Finally, we have a pause here just to slow the game down a bit because this would be a very simple game and would run too fast otherwise. And then we loop back to the start here to do the entire procedure again. And this is really the entire game. There's really very little to it, generally speaking. It's very simple. There's no score or there's no title screen, and the game logic isn't honestly very good. So we saw draw paddle last time. We're just locating 4 consecutive lines and drawing our character in the accumulator. The draw ball is even simpler. We just use a locate command and a print char command. Locate command will take HL and print char will show the accumulator. Of course, if you weren't using my code, you'd need to replace these with some of the graphical routines, and if you were being really clever, you could use sprites or something. Check paddle hit we saw earlier. This is being used to check the player position or the CPU position compared to the ball. So what we do here is we start this routine with BC pointing to the player paddle or the CPU paddle, and we load the ball position into HL. So what we do is we check the X position. Now, if the X position of the paddle is not the same as the X position of the ball, then there's no possible way that the paddle has hit the ball. So we skip immediately to the end of the routine. Now we need to check the L position. If the ball position is less than the top of the paddle, then the ball is above the paddle. And again, there's no way that the paddle has hit the ball. So we need to return. Now we need to add 4 to the position of the paddle because the XY position of the paddle represents the top of the paddle, not the middle. Once we've added 4, we're now effectively pointing to the bottom of the paddle. Again, we check the position of the ball compared to this new position in the paddle, and if the ball is not less than the bottom of the paddle, then it's obviously beneath the paddle, so again we return. So if we get to here, then we need to update the movement of the ball. So we increase D because D records if we need to flip the movement of the ball, and then what we do is we load in the R register, which is a constantly incrementing register on the Z80 and effectively can be used as a crude random number generator. And so I'm just keeping one of the middle bits here and I'm loading this into E. Now what this effectively does is it will, with 50% randomness, flip the Y position of the paddle. So it's just to give a bit of unpredictability to the game. So that's the end of this check paddle routine, and that's actually the end of this code. It's really pretty straightforward, hopefully, and maybe this will give you some opportunity to have a basic template for a game. Now I'm sure you could take this and make it better, and hopefully you could also modify it into a different kind of game if you wanted, you know, There's no reason you couldn't turn this into a space shooter. You know, the two paddles could be turned into ships, and you could use the kind of code that was doing the ball to make a bullet that you could shoot at the enemy, and you could use the check paddle hit routine to see if you've successfully shot the enemy ship. So, you know, it's just a template, and it's, you know, it's nothing special, but hopefully it's something easy to go along with. Now, this version will work on any RAM-based system with a 32 by 24 screen or greater. So it will work just fine on the MSX or the CPC, but it won't work on systems like the Master System or the Game Boy. The Master System because it's a ROM-based system, and the Game because the screen's too small, and the Game Boy because it uses the GB Z80, which isn't a true Z80 processor. But I have created an alternate version called Pong 2 here, and if we run this version, you'll see this does actually work on smaller screens and on the Game Boy here. So with just a few modifications, we are able to convert this game to work on the other systems, but I'm not going to go over the code here because it does make things a little bit more complicated. So I didn't want to go over this because the idea was to have a very basic tutorial for beginners. But if you are interested in playing this on the other systems, this code should work on all of the systems within my tutorials, as all of the stuff I cover in these tutorials. Anyway, I hope you've enjoyed this. Let me know what you think. Thanks for watching and goodbye.